I think it's going. So, you guys heard the term organic before? Yeah. You know, you could say now when you hear it, you hear mostly organic food. So like organic lettuce, organic beef, and all that means is that food has been raised without man-made fertilizers. It's been raised without putting pesticides on it, and so it's pretty clean. But in biology, organic means something else. Something else. And I'm going to just tell you right up front. When you're taking notes for me and you hear me repeat something maybe over and over and over again, but it's not up there, that's probably a good sign that you want to put it down. So like up there, you don't see CHO. C-H-O. You don't see CHO. But if I were you, I would put somewhere on my paper, capital C, capital H, capital O. CHO. 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 It's easy to remember. Fun to say. CHO. Jacob, say CHO.
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 Yeah, see, so it's easy. Now, next thing, besides CHO, is the nature of matter, right? So matter, we're in like, if you were taking college chemistry, this would be like an organic chemistry. This would be like one of the hardest chemistry courses you could take in college. It's not. We're only hitting it really simply, but you're going to see the term matter. Okay, and it doesn't mean like, oh, that doesn't matter. It's more like it's made up of matter. Okay, here's what matter is. Matter is anything. You ready? Is anything that takes up space. Do I take up space?
Yeah. No.
I take up more space than you, Ty. Now, Mr. Stevens, he takes up more space than me. You know who, if I say Hulk Hogan, you ever seen a picture of Hulk Hogan?
I saw him at the Chicago airport once.
He's huge. He's like one of the biggest human beings. He's like 7 foot tall and he's like 450 pounds. He's just a big, muscular dude.
That's me.
So you take up space. And not only does it take up space, but you can weigh it. Well, can you weigh me? Absolutely. Now think about this. Is the air you're breathing matter?
Yeah.
I mean, not that it does matter, but is it made up of matter? Yeah. Because it takes up space. It's filling up the room. And if you could weigh it, it would weigh something. If you don't believe me, if you fan your face and you can feel the air hit you, that's how you know it has weight, because you can push it around. Think about this. Have you ever been in an elevator and you're going up high and then your ears start popping? Do you remember that? Have you ever heard that? Or if you go to the bottom of a pool and it's deep and you can hear your ears pop, because if you go up in an elevator, there's not as much air on you pressing down on you, squeezing you, pressure, so your ears pop. But if you go down underneath the water, all that water's pressing down on you. It's got weight. It's pretty cool. And that's what we're talking about with matter, because it takes up anything that takes up space and has mass. Now, mass is just a fancy way of saying all the stuff in it that can be weighed. Okay? Now an atom. There are 118 different atoms. Now I want you to think, compare an atom to a brick. Remember I told you the room is, this whole school is made up of individual concrete blocks, 8 inches by like 16 inches. But aren't there like different shaped blocks and bricks? Absolutely. There's some small square ones. There's some rectangular ones. They come in all different colors, but they come in different sizes. Atoms come in different sizes. There's 118 different sizes, so they're all unique. Now, the basic unit of matter. See that? That's kind of, you're like, well, what's that mean? Basic unit. What is the smallest part of matter? So if you look at gold and you tear it apart, atom by atom, you can't spread it down to anything smaller than an atom. Because if you do, then it's not gold. Or iron, or copper, or carbon, or oxygen. It's the smallest unit of matter. Like this building. That really is like the smallest part of the building that is built with the structure. So the blocks, those are the smallest units of this humongous building. Okay, so, and then it's made up of 3 particles. We talked about that Friday. We already talked about it. Proton, neutron, electron. Well, if you look, proton, and you see that positive sign up there, if I were you, I would probably put that in my notes as a reminder that it's positive. Now that doesn't mean it's happy and got a good attitude. That means it's a positive electrical charge. So if you would come over here and stick your finger in a light socket, that's what I'm talking about. That kind of electricity. It's that kind. Okay? And then it's found in the nucleus, which most people know. Okay? Has a positive electrical charge. Test question. Test question. I'm trying to remember which one are the test questions. There's a lot of them. And if you're taking notes, you're at advantage. Okay. Protons. Positive electrical charge. Found in the nucleus. Now, you don't have to write anything here because this is wild. Okay, so every science classroom has one of those hanging out. It's a periodic table of elements. Okay? If you look, there's carbon, right? Next to it, nitrogen, oxygen, fluorine. Anyway, you get the idea. The reason I want to show you this is because the atoms in here, they start with the smallest one. Remember, the only way they're different is how big they are compared to each other. So this is the very smallest one. He's got a number 1. And if you go across to number 2, then it keeps getting bigger and bigger and bigger and bigger. So if you could hold one in your hand, this would be the heaviest one, way down here, 118. And we're going to come back to this. This is pretty cool. Cho. Remember Cho? Don't forget about Cho, our friend Cho. Okay? Now, here's the other particle that makes up an atom. This is also found in the nucleus. Test question. Called a neutron. How many of you are you like when World War II or World War I stuff comes on? Do you like that kind of stuff?
Yeah.
I love it. When I was in school, I thought I really dig it. And if you really like that kind of stuff, that history part, you could probably answer this question. World War I, World War II. There was one country in Europe that didn't take sides. If you know it, great. If you don't, no big deal. Starts with an S.
Sweden.
Not Sweden. Switzerland. Never took sides. Never, ever. And you know what? Germany didn't take it over. Allies didn't take it over. But it didn't pick sides. So if it's not picking sides in a war, we say it's what?
Neutral.
It's neutral. Now, neutrons. Neutral. That means, well, what's it neutral about? Look here. No electrical charge. So it doesn't have, you could hold one, it's not going to pop you. It'd be heavy. If you could blow one up like this, it'd be so heavy you couldn't pick it up. But it has no electrical charge. And it's always found in the nucleus. If it's there at all. If it's there at all. Now, check this picture out. Knowing what I just told you, if I expand that, here's a nucleus. Okay? I'm just going to tell you up front. Let's just say this is a nucleus. Here's a positive charge. Here's a positive charge. What do we say these were that had a positive charge in an atom?
Protons.
The protons. These zeros are neutrons. They don't have a charge. So let me show you something. You don't know what element this is, but I'm going to show you a really easy way to figure it out. 1 positive, 2 positives. Watch this. We're going to go back to the chart. Go back to the chart. See where that one says number 1? Oh, we must be pretty close. If you go over, see the number 2? So, what was it? Helium. You know that stuff you breathe in and it makes you sound funny?
Helium.
Yeah, it's very rare on Earth. You have to make it. We have to make it in factories. We can't get it naturally. Now, if you go to the sun is loaded with helium. You'd sound funny there if you could even stand the heat. Okay? And so that's kind of what that is. Now, the last, the particle, and I would say I would argue with a lot of people that, yeah, protons are important. But the electrons, they're kind of big. These things are not big as in size, but they're big in importance. Hopefully, please, you're taking notes and you're listening. The electron is like one of the smallest things we know. And so when you do pee on an electric fence, or stick your finger in a light socket, or get shocked, or you see lightning hit a tree, which hit my tree here about a week ago. Destroyed my tree. It's all electrons. So electricity is electrons. And look how big it is compared. If this is the proton, and this is even not a good representation, this would be way smaller because it's like 2,000 times smaller than a proton. But look what charge it has. It has a negative electrical charge. Negative electrical charge. So Mr. Dobson feels really funky. I go over here and I like zap. I get zapped. Those electrons are going through my body. And like if you would ever touch an electric fence and you know how it'd jolt you? It's like, oh, there they go. All these electrons, billions of them going through your body. So, but it's all negative electrons. Lightning, same thing. It's made of nothing but these things. There might be some positive in there, but mainly just that. Now, remember I said please add stuff? Where my finger is, well, in fact, I'll just draw it. Let's say this is a nucleus of an atom. The electrons are around it. You find it around it. And they do this constantly. That's all they do. What does the Earth do to the sun in relation to the sun?
It orbits.
It orbits. So the electrons do nothing but constantly circle an atom. Okay? Constantly circle. They orbit it. Test question. That would be something I would know. Okay. Moving on. I think this is almost done here. You got two more things. An element. Look at that gold bar. I have on my bucket list, and I know I will never be able to do this, but I want to hold a solid gold brick. I want to hold it. It's like, what, 50, 60, 70 pounds? A big brick like this. That little thing, it looks like a brick, is about 70 pounds. It's so heavy. Have you guys ever watched the old westerns where the old guy's panning in the water for gold? How does he know he's got gold? What's he do?
Does it look a bit shiny?
Well, if you see it, you're going to look at it, he's going to pick it up. Oh, it looks like gold. But how do you tell?
Bites it.
Yeah, he bites it. Because if he can bite it and he leaves a mark in it, it's got to be gold. If he bites it and it breaks his tooth, it's not gold. Now, this is pure gold. This is only 10.5 ounces, and I think the price of gold right now is $1,500, $1,500 per ounce. So this would be worth roughly, what, $15,000 for just 10 ounces of gold? Imagine what a brick would go for. But what's so cool about this, that this is the element gold. This is what one atom looks like of gold. Okay, it's just somebody's drawn it in there. Look at that. It's a big one. It's got 79 protons. And look at it. It's loaded with neutrons. It's really big. It's really big. Now here's what I want to show you, a little connection here. And if I were you, I'd write this down somehow. But if there's always 79 positive protons, if I count all the electrons, when I go through it, there's going to be 79 electrons. Not crazy? Always. Any element, any atom on that chart, protons are always equal to the number of electrons. So if it has 30 protons, how many electrons is it going to have? If it has 30 protons, how many electrons is it going to have? 30. If it has 25 protons,
25.
what if it has 25 electrons?
We'll have 25. The other one?
25 protons. That's just the way Mother Nature works. That's awesome. So, where it says element, there's 118 of them. Elements are made up of atoms. So this is the element gold, so you're only going to find what kind of atoms in it? Gold. Atoms. So atoms make up elements. Atoms make up elements. Atoms make up elements. Okay? Pure substance made of one type of atom. So you could look through here at every atom one by one. You will never find anything in there other than gold atoms. Make sense? Pretty easy. What if I had a silver bar? I'm only going to find what kind of atoms? Silver. Remember, the smallest part of any element is an atom. Smallest part of any element. So if I hold a diamond in my hand, it's made up of carbon that we kind of breathe out too. So you could break it down and look at the smallest atom in it, and it's going to be a carbon atom. It's pretty cool how it works. Now, CHO. CHO. There's 24 elements found in the body. You don't need to know but 3. And I'm going to prove to you already know them. CHO. CHO. All right. Hey, good question. 24 elements found in the body. Check out this picture. Look at this. 65% of the body is made up of oxygen. Carbon, 18%. Hydrogen, 10. 3 nitrogen. And then the other 20 are in smaller numbers. I don't even think I know them. I couldn't name them all. Like, some people need iron. That's one of them. Some people need zinc. We do have traces of gold in us. Nothing worth going after. Magnesium, yep. You're going to have that. And here's another way of looking at it. If you weigh 100 pounds, you have 65 pounds of oxygen in you. If you weigh 100 pounds, then you have 18 pounds of carbon. See how it works? So if they were to take all your water out of you and disintegrate you, 18 pounds would be carbon. I'm like 200 pounds, so I'd have like 36, 100, and what would that be? 130, 20. That's too much math. But you get the idea. These are the big 3. C, H, O. CHO. So if you look at a molecule that we're getting ready to talk about, and you notice it has carbon, hydrogen, and oxygen, it's organic. That's what they call organic. It's CHO. Organic. CHO. Okay, last thing. Then we're going to get into a lab. Don't where it says chemical bonds, don't take it. So here's your last thing. Remember, atoms make up elements. Atoms make up elements.
Oh, wait.
Molecules make up compounds. Lay it on me.
Oh, you just completely skipped C.
That's okay. You're going to find that over the years I've taken things out and I haven't put them back in. So you're good. You'll have everything. Now you're going to hear me say molecules a lot. And a lot of people, they don't know what a molecule is. Well, you got to understand what a compound is. So if you like milk, milk is made of 2 or more different things. That's a compound. Concrete. You ever mix concrete? Yeah. In goes some sand. In goes the concrete mix. A little water. See, it's made up of several different things. You may even put, for strength, you may even put gravel in it. That's a compound. So it's really no different in biology. If you're adding carbon and hydrogen and oxygen together, that's a compound. But they also come in molecules. So molecules form compounds. Okay? Now, 2 or more atoms joined together make a compound. 2 or more. And I'm going to show you. You guys already know some. Look, what's this? It's water. Yeah, look, right here. H2O. See that 2 right there? That means there's 1, 2 hydrogens. See that? Pretty easy, isn't it? It's pretty easy. But you notice you don't see a number back here behind the oxygen. So what's that tell you? There's only 1. Because you see it right there. And so that is a molecule of water. That is a molecule of water. Down here, CO2. What's CO2?
Carbon.
Carbon dioxide. See, you guys know something. How many carbons are you going to see in one molecule of CO2? 1. How many oxygens?
2.
In this case, it's probably, if I remember right, it looks like this. This would actually be a bigger. Look at that. Isn't that 2 or more? Yep. So that must be a molecule. Now, anybody know what this is? This bad boy. What is it?
Sodium chloride.
Sodium chloride. What do we call it?
Salt.
Salt. Table salt. Look at this. Sodium, if you eat it, you're dead. If you breathe chlorine, you're dead. But when they go through a chemical reaction, they make table salt and we can eat it. Because if we don't get it, then we die. We got to have it. We get enough salt in our diet. We don't have to add. You're like me. I'm always salting everything. But look at it. How many sodiums you see? One. One. But see, these are examples of molecules. The air we breathe, it's called O2. So it's oxygen connected to another oxygen. It's a molecule. So they don't always have to be different. They can be the same. They can be the same. Okay, any questions? Smallest part of any element is an atom. Smallest part of any compound? Face that word. Molecule. All right. I think I'm done with you.